If you haven't already heard, our solar system is currently hosting a strange and intriguing visitor. Comet 3I/Atlas exploded onto the astronomical scene in early July 2025, when it was first identified by the NASA-funded Atlas Survey Telescope, the Asteroid Terrestrial Impact Last Alert System, operating in Rio Hurtado, Chile. The moment astronomers calculated its trajectory, they realized they were looking at something extraordinary, an object from beyond our solar system, traveling on a hyperbolic path that could only mean one thing. This was interstellar. Since that discovery, scientists across the globe have assembled in an unprecedented coordinated effort, collecting every scrap of information they can get about this elusive entity. What followed was nothing short of a scientific explosion, a flurry of articles, emergency telescope allocations, rapid-fire research papers, and yes, even controversies about this first interstellar visitor to enter our cosmic backyard in 6 years. But amid this media frenzy, what have we actually learned? What information about this comet is verified science, and what still lies in the realm of speculation? More importantly, why are some of the world's most respected astronomers calling 3I/Atlas the strangest object they've ever observed? I'm Alex McColgan, and you're watching Astronomy. Join me in this video as I give you a much-needed update on 3I/Atlas, piercing through the noise and getting to the heart of what makes this visitor so genuinely bizarre, just in time for its October 30th perihelion, when it will disappear behind the sun's glare for weeks, potentially changing forever or even fragmenting completely. If nothing else, the sheer velocity of research around this comet proves how dynamic the world of modern science can be. When I made my first video about 3I/Atlas back in July, there were only around 4 published research papers naming it. Now, at the time of writing in late September, there are nearly 70. That's not just growth, that's a knowledge explosion, representing a huge volume of new discoveries, corrections to initial assumptions, verifications from multiple instruments, and collective leaps in our understanding of this object. But here's what makes the 3I/Atlas story so compelling: with each new observation, instead of the mystery resolving, it's actually getting stranger. Let me give you a quick recap of where we left off, and then dive into the discoveries that have left astronomers genuinely puzzled. In my previous video, I discussed the initial discovery of Comet 3I/Atlas, named for its status as the third interstellar object to visit our solar system, following the designation convention established by Oumuamua, the first interstellar visitor discovered in 2017, and Comet Borisov, which arrived in 2019. But 3I/Atlas is different from its predecessors in some remarkable ways. It's faster, traveling at a staggering 58 kilometers per second, making it one of the fastest objects ever tracked through our solar system. It's older. Spectroscopic analysis suggests it formed somewhere between 3 and 11 billion years ago, potentially making it older than our Sun itself. And unlike Oumuamua, which remained frustratingly enigmatic due to its rapid passage and faintness, 3I/Atlas is bright enough and slow enough, relatively speaking, to allow detailed study. That was a speedy summary, so if you want the full context, you should definitely check out my first video, which you can watch at the link here, for more in-depth information about the discovery circumstances and initial observations. But since 3I/Atlas made its debut on this channel, we have learned substantially more about it, thanks to literally thousands of hours of observation time and measurements from astronomy facilities spanning the globe and orbiting in space. And what we've learned has systematically challenged almost every initial assumption. So, what's the latest information to emerge from this international research effort? And more importantly, what are the anomalies that have even veteran comet researchers admitting they've never seen anything quite like this? With the worldwide recognition that 3I/Atlas has attracted since its discovery, it has managed to turn the attention of 2 of humanity's most prestigious and powerful astronomical instruments, telescopes that don't normally divert from their carefully planned observation schedules. It's famously difficult to schedule observation time with NASA's Hubble Space Telescope. Scientists typically must submit detailed proposals months in advance, competing with hundreds of other researchers to argue their case for every precious minute of the telescope's time. The approval process is rigorous, and the wait times can be frustrating. But fortunately for 3I/Atlas, Hubble always reserves a small portion of its schedule for what astronomers call targets of opportunity, objects that need to be observed immediately before they move out of reach or change in ways that make later observations less valuable. These are the astronomical equivalents of breaking news, and 3I/Atlas qualified instantly, giving this unexpected interstellar visitor a free pass to skip the months-long queue. And the Hubble observations were absolutely worth the schedule disruption. On July 21, 2025, when 3I/Atlas was approximately 446 million kilometers from Earth, roughly 3 times the distance between Earth and the Sun, Hubble captured a stunning image of the comet. You can actually see the speed of this object reflected in the background of the image. The stars appear as streaks rather than points, because Hubble had to track the comet's rapid motion across the sky during the exposure. The comet itself shows the classic teardrop shape, characteristic of active comets, with dust streaming away from its icy nucleus as volatile materials sublimate in the increasing warmth of the inner solar system. But these observations did more than just produce beautiful pictures. They allowed Hubble scientists to make critical corrections to our understanding of 3I/Atlas's physical size. By carefully analyzing the image and separating the brightness contribution of the nucleus from the surrounding coma, the vast cloud of gas and dust that envelops the solid core, researchers determined that the nucleus itself is actually much smaller than initial estimates suggested. The revised size range places the nucleus somewhere between 440 meters and 5.6 kilometers in diameter. That makes 3I/Atlas significantly smaller than we originally thought. Initial estimates had assumed that most of the comet's brightness was coming from the solid nucleus itself, but Hubble's superior resolution revealed that much of what we were seeing was actually light reflected from the extensive coma. This correction is crucial because it fundamentally changes calculations about the object's mass, density, composition ratios, and the dynamics of its outgassing activity. And now that we have more accurate measurements, future observations, particularly as the comet continues approaching the Sun and potentially brightens further, may allow us to pin down these dimensions even more precisely. The other astronomical heavyweight that has turned its sophisticated instruments toward 3I/Atlas is the James Webb Space Telescope, humanity's newest and most powerful eye on the cosmos, specifically designed to observe the universe in infrared wavelengths that reveal chemical compositions invisible to other instruments. What Webb discovered about 3I/Atlas's chemistry is where the story starts to get genuinely strange.